Hello and welcome, my dear students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to part 2 of lesson 1.1 Introduction to Vectors for all my grade 11 elite math students. So today's session will be working on vector problems. So let's dive into the video and see what we are learning today. The learning objectives of today's session would be first to recall the vector basics and all the important formulas that we've done in part 1 and use them to solve vector problems and resolve the vector into their rectangular components. Towards the end of this video, I will be sharing with you some of your math textbook important problems on vectors. So make sure you watch the video towards the end. And if you like the video, do give it a thumbs up. Share with your friends who will find it useful, and do subscribe to the channel if you haven't. Kind reminder to hit the bell icon so that you don't miss the notifications about my upcoming videos. So let's recall vector addition. So if you have two vectors like this, vector u and vector v given to you, and you want to add them both, then you first place the initial point of the first vector. For example, I'm taking vector v at the terminal point of the vector u. So you put them in this way, and then you draw the vector with the same initial point as u. So you start from the tail of v and you join the top of u. So u plus v, this is triangular law of addition that we've used to find the resultant u plus v. For vector subtraction, you just have to change the direction. So if you have u and v, then place the initial point of v at the initial point of u. So you are changing the direction, you are making it minus v. So the direction is changed, and then you find the resultant by joining the tail of the top of v with the top of u. So draw the vector u minus v from the terminal point of v to the terminal point of u. Now, a vector with the initial point 0, 0 in the standard position, and it is represented uniquely by the terminal point. So this you can see from 0, 0 from the origin. You always put in standard position the vector where the horizontal component is u1, the vertical component is u2. So x comma y. So x component is u1, y component is u2. So if the vector has an initial point p and q given by p1 comma p2 and q1 comma q2, then you subtract the components x with x. So q1 minus p1 would be the x component of the component, and q2 minus p2. So just subtract them to get the component, and p and q, these are the points on the graph. Now to find magnitude, you use Pythagorean theorem. So you take sum of squares of the component. So q1 minus p1 whole square plus q2 minus p2 whole square, and then you take the square root. Magnitude is denoted by the vector in the bars. So this is the important formula sheet. So let's solve a question. You are given a vector pq such that the initial point p is 3 comma minus 2, the final point or terminal point q is minus 1 comma 1. So you need to find the component form. So you will subtract the components, that is minus 1 minus 3, that will give you minus 4, and minus 1 and 1 minus of minus 2, that is 3. So you are subtracting. Which formula are you applying? q1 minus p1, q2 minus p2. So that's what is the component. So you get it as minus 4 comma 3. Now for magnitude, we'll apply the Pythagorean theorem. So minus 4 square plus 3 square, which is a perfect square of 25. So 5 is the magnitude. Now two vectors are equal if and only if their components are equal. So the x component u1 is equal to v1, the y component u2 is equal to v2. So this is all about equal vectors. For example, if you are given vector PQ, RS, TU with P, Q, R, S, T and U given here, determine which of U, V and W are equal. So we need to find their components. Let's find. So first the component of the first vector PQ. So you subtract 4 minus 1, 3 minus 2. So this is 3 comma 1. Then you find vector v, which is vector s minus r. So it is 2 comma 1, and similarly w, which is this. So you can see these two are equal, but this is not equal. So we can conclude by saying v is equal to w, but v is not equal to u, and w is not equal to u. So you have to check for component form to check for equal vectors. Now let's revise about operations. Operations on vectors in the coordinate plane. If you are given the component x1 comma y1 x2 comma y2 and a scalar, then scalar multiplication means it is distributed on the components. So c times u is c times x1 comma c times y1. Similarly, addition means you are just adding the components. So x1 will be added to x2, y1 will be added to y2. So you get this. Subtraction means they will be subtracted the components. And let's take an example. So two vectors are given, u and v, with the components. You have to find minus 2 times u. Means you take this vector u and multiply negative 2. So answer is this. Then you find, and if you want to do the graph, u is here, minus u will be opposite direction. So minus 2u is double the magnitude but in the opposite direction. Then u plus v, just add them up, so it will come out to be the resultant 6 comma 7. This is how the graph will look like. You can have a look. So 2 plus 4 gives you 6, 5 plus 2 gives you 7. Similarly, for subtraction, you just subtract them and the graph will look like this. U minus v will come here, 2 comma minus 3. So this is how vector operations are done. I hope you have recalled, and let's dive into today's concept. Also, you should know how to find the direction angle. By definition, for a vector v, the angle is formed by the positive half of the x-axis and the ray along which v lies. So if you see this diagram, x and y component, this is vector v. So the angle which is made theta here in the anti-clockwise direction is the angle formed by the positive half of the x-axis. So this is the positive x-axis and the ray along which y lies. So this angle is theta. How do you find this theta? Let's do it. So this theta can be in this form, acute angle or obtuse angle. And if you're given the vector x and y component, then tan of this theta is y over x, means opposite over adjacent. So you remember, for tan the formula is TOA, so tan theta is opposite over adjacent. So that's how you get y over x, and theta would be tan inverse of this angle. So if your vector is 3 comma 4, then tan theta is 4 by 3. So theta would be tan inverse. You can use your calculator and this will come out to be roughly equal to 51.13 degrees. Remember, here x is the horizontal and y is the vertical component for the vector v that we are taking. Let's solve a question on area of triangle. Here you need to find angle BAC. So angle BAC is this angle, and you are given two vectors AB. So AB vector in component form is 3 comma minus 2. AC vector in component form is 1 comma minus 5. So this angle in between AB and AC, that angle you have to find. So sometimes we have to use cosine rule also to find the angle. So here, how you will use the sine rule, we need the length of the three sides of the triangle. So let's find the length of AB, which is magnitude of AB. So how will you find? Let's see, I will write here for you. So magnitude of AB vector is this component, Pythagoras theorem, plus this component. So this is 9 plus 4, that's why square root 13. Similarly, magnitude of AC, how will you find? You will use the same formula. So here it will be square root of 1 square plus minus 5 square. So which is square root of 1 plus 25. So it will come out to be square root 26. Okay, we have these two sides. Similarly, can we find the third side? Yes, 2 comma 3 is given. So you can find its magnitude as square root of 13. So you have all the three. Now that you have them, you have small a, small b, small c. So you can put it in the cosine rule and get what is the cosine rule. Let me write here for you the formula in case any one of you have forgotten. So cos a would be AC square plus AB square minus BC square over 2 times AC times AB. Okay, so what is this value? Let's put in. So AC square would be 26 plus 13 minus 13 over 2 times AC, which is square root 26 times square root 13. So you simplify this and this cancels. 26 over 2 times 13 times square root 2. So this is 1 over square root of 2. So you got cos of A as 1 over square root of 2. So if cos of A is 1 over square root of 2, A is cos inverse 1 over square root of 2, and this happens at the angle of 45. So cos of A equal to 1 by 2 gives you angle A is 45 degrees. So angle BAC, final answer is 45 degrees. Okay, let's look at an example for vector diagram. So here you are given two vectors, as you can see, vector x and vector y, and you need to draw the graph of 3x minus 3 by 4 times y. That means 3 times x, so 3 times the size of this. So if your x is this much, then 3 times its size is 3x. So this is how vector 3x looks like, first vector. Second vector is minus 3 by 4 times y. So if y is in this direction, minus y would be in this direction. So that's why it's going down. And you multiply it with 3 by 4. Now 3 by 4 is less than 1. That means size decreases. So that's why 3 minus 3 by 4 y is this one. This is the second vector. Now you need to add them both. You need to find the resultant. So the addition of the two vectors, this and this, would give you the answer. So we use triangle method to find the resultant. So if this is the first vector, this is the second vector, then the resultant is from the tail of the first vector. So tail of this vector is this point, to the tip of the second vector. The tip of the second vector is this. So the green vector 3x minus 3 by 4y represents the resultant. So the green vector is the resultant. That's how you draw, that's how you graph. Let's solve some questions from your book now, as promised. So first of all, congratulations. If you've reached this part of the video, means you've watched the video and now you are ready to do some questions from the book. So let's do it together. Here you are given three vectors, 1, 2, 3, and you have to add them both. So A vector will be as it is, that's the first vector. C vector has a negative sign. So if C is in this direction, the green one, I will use the same color, then minus C would be parallel to it but in opposite direction. So first let's draw with the same colors. The red one, this is A vector, then the green one, which is from here to here, negative C vector. So that's the one, and then 2 times B. So if this is B, I'm using blue only. 2 times B would be double the size. So this is 2B. Now I draw 2B also. So where I'm drawing 2B, I'm starting from here and drawing it here. So 2B. Now the resultant, I'm using black. So the resultant is this vector plus minus C vector plus 2B vector. So I'm going to add them all. So first vector tail to final vector tip. So this is the tail of first vector. This is the tip of third and the last vector. So if you join them, what you get is the resultant. So resultant vector is A minus C plus 2B. So that's how you draw, and you can check your answer. It is correct. Similarly, this one is more easy, 4b. So you have m as it is, and you are adding to m minus 1 by 4p. So you are reducing the size and changing direction. So if m is like this, minus p is here, then from the tail of the first vector to the tip of the last vector. So m minus 1 by 4p will be here. Check your answer and draw them in your notebook. Okay, so let's solve another important question from your math book. Here, a player is kicking the football so that it leaves the ground with a velocity of 44 feet per second at an angle of 33 with the ground. So you can see this player is kicking and it is going in this arrow in this direction, the ball, and it's forming a parabolic path. So the velocity is 44 feet per second. This is the vector v given to you, and the angle or the direction theta is 33 degrees. Draw a diagram that shows the resolution of this force into rectangular components. Very easy. So you have a right triangle coming up because this is the direction of the vector 44. This is the horizontal. With horizontal it is making 33. Just excuse me for not a perfect horizontal because I'm not making it from a ruler. Yeah, this looks better. So this is the angle, and along the horizontal, x is the component, along the vertical, y is the component. So here 90 degree comes up. So when I have a 90 degree, the x component and y component, we can do our trigonometry now, SOHCAHTOA TOA. So I'm looking for vertical and horizontal, so I'm just going to use sine and cos. So sine of 33 would be opposite, which is y over hypotenuse, which is 44, and similarly cos of 33 would be the horizontal component, adjacent over hypotenuse 44. So when you have to find your x and y, you are going to just multiply this with the angle values. X and y, oh sorry, here it is y, here it is x. So 44 cos 33, you can do it from your calculator, and roughly for the second part, the magnitude of the horizontal, which is x, will come out to be roughly 36.90 feet per second, and for the vertical using sine, y will come out to be 23.96 feet per second. So that's how you use sine and cos, how you use trigonometry, how you use SOHCAHTOA for finding the horizontal and vertical components. Remember, x always represents horizontal component, y represents vertical component. So that's how you'll solve a question. And with that, a learning objective of resolving the vector along the horizontal and vertical components is done. That brings us to the end of today's session. Thank you for watching. If you found the video useful and it helped you in learning of vectors, do give it a thumbs up, share with your friends who will also benefit from the same, and subscribe to the channel if you haven't, and make sure you press the bell icon so that you don't miss my next video. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.